All right, geometry, in this last video, we're going to go ahead and go over the solution to example 3. So I've already gone ahead and given myself a sketch of the problem. So I've plotted all of the vertices and connected them all together. And the question is trying to figure out what is the most precise name for the quadrilateral. And so let's go ahead and figure that out. So there's a number of things that it could be. It could be a square, it can be a rectangle, it can be a rhombus. I'm not sure if I spelled rhombus right. It could be a kite, it could be an isosceles trapezoid, or it could just be a regular trapezoid. Okay, so let's go ahead and just start off by ruling out some of these shapes. So I know it's not a square because CD has length 1, 2, this is 3 units long, and 1, 2, 3, 4, 5, 6. AD is 6 units long, so I know it can't be a square, and I know it can't be a rhombus because in both of those, all of the sides have to be the same, and they're different. And it also cannot be a kite because those two consecutive sides are not congruent. And we can go ahead and double check that with BC. So BC has length 1, 2, 3, 4, 5, 6, 7, 8. This is 8 units long. So now I know for sure it's not a kite. I also know for sure it's not a rectangle because the opposite sides are not congruent. So the only thing I'm left with is a trapezoid or an isosceles trapezoid. And I know it can't be a trapezoid or an isosceles trapezoid because this distance is not going to be the same. So when I do Pythagorean theorem, this leg is 2, 1, 2, 3. This leg is 3. I end up with 2 squared plus 3 squared equals c squared. This ends up being the square root of 13 equals c. So this side length right here measures the square root of 13, which is not 3. So it must be a trapezoid. Now, in a trapezoid, we only have one pair of parallel sides. Let's go ahead and just kind of show that really quick. So the slope of BC, well, since it's just a horizontal line, it's 0. The slope of AD is also 0 because it's another horizontal line. And if you're curious about what the slope of CD is, well, for vertical lines, those are undefined. So there we go. We've shown that BC is parallel to AD, and that is the only side of parallel sides. Let's go ahead and check BA. So the slope of BA is going to be 1, 2, 3. So down 3 and over 2, so -3 halves. Now I know that I only have one pair of parallel sides, and I'm good to go.